Welcome to myprojectprasad.com. Let me discuss about the process multiple target localization using wideband echo chip signal. Let me discuss about the process multiple target localization using wideband echo chip signal. In this process, we are going to identify the targets in the path. For that, first we are generating a wideband signal. For here we are generating the wideband signal not using the sensor array but using some random functions. We are generating the wideband signal. After the signal is generated, it is transmitted. The signal has to be reflected by some targets. Here the targets were specified by the user and they are randomly generated, and the generated targets and the signal is reflected from the generated targets. The echo signal is generated during the reflection, and using the reflected echo signal we are obtaining the range, radial velocity and DOA of the echo signal. Here the range represents the position of the target, radial velocity represents the velocity of the target, and the DOA represents the direction of arrival of the target. In order to obtain the range of the target, we are using LCT, linear cosine transform. Then in order to obtain the radial velocity, the target's location was used, and then the velocity is calculated. And in order to obtain the direction of arrival of the targets, we are using music algorithm. So finally we are getting the range, radial velocity and direction of arrival of the targets that we have specified. Let me discuss about the flow of the process multiple target localization using wideband echo chip signal. In this process, initially the wideband signals were generated from the sensor array. Here we are not using the sensor array. We are creating the wideband signal by using some random functions. Wideband signals are radio signals which are short signal pulses over a broad spectrum. An ultra wideband signal generated at 5 GHz typically extends between 4 GHz and 6 GHz. The wide signal allows the ultra wideband to commonly support high wireless data rates of 480 Mbps up to 1.6 Gbps at a distances up to a few meters. At longer distances, ultra wideband data rates drop considerably. The generated wideband signal are modulated using QPSK modulation. QPSK is a type of phase shift keying, unlike QPSK, which is a BCS modulation. The amount of radio frequency spectrum required to transmit QPSK wavelength is half of that is required for PPSK signals. The two PPSK signals are then simply added together for transmission, and they have the same carrier frequency. They occupy the same portion of the radio frequency spectrum. While this suggests the two sets of the signals will be identically mixed, and the return 90 degree of the phase separation between the carriers allows the sidebands to be separated by the receiver using the phase description. Then after generating the wideband signal, we are initializing the target. In order to initialize the targets, here we are using some random functions. Target here represents any moving or stationary objects within the range. The number of targets was specified by the users while running. Then echo signal is generated. The wideband signals are generated and they are transmitted by the sensor array. Sensor array is a group of signals deployed in a certain geometry pattern. The advantage of using sensor array over the signal sensor lies in the fact that an array can increases the antenna gain in the direction of the signal while decreasing the gain in the direction of the noise and the interfaces. In other words, sensor arrays can increase the signal to noise ratio, amplify the signal while suppressing the noise. Another relativity of the sensor array is that it can detect the direction and the distance of the emitting signal sources. The technology to achieve this is called as an array. A radar type is a type of sensor array. We use radars in this process. The wideband signal is reflected by targets and the echo signal is generated. The generated echo signal is generally very noisy. Now the echo signal is reflected by the sensor array and we are echo signal. Actually, we are generating this echo signal by just denoising, by just adding some noises to the main sequence. We are not using a real sensor array. Then we are estimating the range, radial velocity and the DOA of the input of the targets which are present in the particular region. So for estimation of range, we are using LCT, linear cosine transform. The range of the target describes the distance between the target and the source of the signal. Then the velocity of the object is calculated. Radial velocity is the velocity of the object in the direction of the line of sight Each motion with a given velocity has a direction. It is a vector, therefore, in relation to the director of the observation, the motion vector can be broken down into two components. The motion along the radial, either directly towards or away from the observer, is called as a radial velocity. Motion perpendicular to the radial is called as a tangential velocity. Thus, we are accompanying the then we are getting the DOA. So DOA denotes the direction from which usually propagated wave arrives at a point where usually a set of sensors are located. This set of sensors forms uh, this set of sensors forms what is called a sensor array. Often there it is associated technique for beamforming, which is estimating the signal from the given DOA. Estimation is important in many sensor systems such as sensor, radar, electrical surveillance, and seismic exploration. High resolution frequency estimation is important in numerous applications. Recent examples which include design and control robots and large flexible space. Let me discuss about the execution of the process. Multiple target localization using wideband echo chip signal. If you want to run the code, select the file radarsimulation.m, which is located in the source code folder. Right click it and click on run file. You will get the guide window which is needed in order to run the code. So here, first click on generate wideband signal. So when you click it, the input wideband signal is generated and it is displayed here. Then we are starting our target localization. So then we are analyzing the buffer, that is we are calculating the range DOA and velocity of the input signals. So here we are this is the transmitted signal and this is a received echo signal. Then this is the combined signal and this is the phase angle of the corresponding signals. Then we are displaying the targets. So here we have identified two targets. These two targets were initially created by us using some random functions. Then we are estimating the parameters of the targets. So first we are finding the range. Here we are calculating the range and then the range values were displayed. The target coordinates were displayed here. Then the velocity of the target is calculated and then the DOA of the target is calculated here. And then finally, for measuring the performance, we are using this. So here we are measuring the error rate for each target and with comparing single target, multiple target and 3 targets like that. So we are drawing a graph based on that. So thus we are producing a system which automatically identifies that multiple targets which is in the radar path and find the target coordinates its velocity at the direction of arrival of the input target. Thank you.